Hello. I recently made a video about Muse, which is the main project that I'm working on for my gap year. In that video, I mentioned the ego and the long-term memory. One of the papers that I'll be taking as inspiration, especially for the ego, is this one, Generative Agents, Interactive Simulacra of Human Behavior, which is basically just putting a bunch of ChatGPT agents inside a town and seeing how they work. They have a certain memory architecture where they're able to perceive the environment that they're in, and then it's sent to their memory stream. And then from that, they're able to plan and reflect on that memory stream in order to commit specific actions and act within the world that they're operating. The thing is, as I made a note here, there's no encoding process. So this is a very, very rudimentary memory system, which makes sense because I don't think the memory system was the main focus of this paper. But there are a few problems with it. Like, for example, and they mentioned this in the paper. I'll see if I can find it while I explain it. But basically, there's, as I mentioned, the memory stream. And in the memory stream, the things that the agents perceive are added to it. So if they spend a lot of time perceiving stuff, then the memory stream here just gets longer and longer and longer and longer. The retrieval method, as they outline here, architectures implements a retrieval function that takes the agent's current situation as input and returns a subset of the memory stream to pass to the language model. So basically the way that this works is each memory or each thing inside the memory stream, let me swap to my right hand and grab my pen. Each thing that it perceives inside the memory stream is first assigned an importance value. So the importance value is something they explain down here. So for example, on a scale of 1 to 10, where 1 is purely mundane and 10 is extremely poignant, rate the likely poignancy of the following piece of memory. Buying groceries at the Willow Market and pharmacy. Rating, fill in. So then using this prompt for this memory, it filled in, or for example, it filled in 2 for cleaning up the room and 8 for asking your crush out on a date. So basically, things that are added here have an importance factor. Then they also have a recency factor, I believe, here. So memories that were recently committed to the memory stream have a higher weight or will be retrieved easier than older memories. And then there is the relevance. So the relevance is calculated by using this retrieval function, which goes through with the current situation through the memory stream and assigns a relevance to the current situation, and then it gets the most relevant memories to prompt the large language model for what the character would say. The thing about this is that as the memory stream gets longer and longer and longer, the retrieval function has to go through more and more and more things to actually find relevant information. And so that becomes a problem. And I believe they actually mention further in this paper on no, where was it? Nope. Or it would be in limitations, which I believe mentions somewhere in here that these models broke down after a little bit because there was just too much information to actually parse through, which is a problem if I'm planning to make a continuously learning synthetic entity. It needs to be able to parse through information fine. Now we go back to this. So as I said, it perceives stuff, and the things it perceives immediately goes into the memory stream. For us humans, we actually have a process called encoding, which is between our perception and our long-term memory, where it will perceive something and it goes into our sensory memory, and then we have an encoding process that can basically commit stuff from our working memory or sensory memory. I'm actually not 100% sure. That's something I should check, but I don't have I should check that. But we have an encoding process. So after we learn something or after we perceive something, it's encoded in some way, shape, or form before it's added to our memory stream or our long-term memory / memory bank. And this model doesn't have that. And the encoding process is what connects it back to other things that are similar to it. Basically, I think this encoding process that was skipped here is quite crucial to making a memory stream that doesn't scale, that the search size doesn't scale with how many memories there are. Because you can just find relevant memories easier if memories that are similar to each other are connected with each other. So I think this encoding process is actually quite crucial to making a effective retrieval process. But I'm not 100% sure. So that's what I'm thinking about right now. I just reread this paper. I was on a train today and I just reread it on the way here and made these cards, or this card. But yeah, I'm planning to take inspiration from this to at least create the ego, because another part of this paper is the reflection. Let me see if I can find that. Reflection. So basically, it gets observations and then gets them to reflect on those observations. So for example, like Klaus Mueller is reading about gentrification, Klaus Mueller is reading about urban design, and then as a reflection, Klaus Mueller spends many hours reading. And all of these together, including this reflection, turns into Klaus Mueller is engaging in research activities. This one, which is a plan, Klaus Mueller is dedicated to research, and then from more observations, Klaus Mueller is dedicated to research, and then the final reflection, Klaus Mueller is highly dedicated to research. So basically, by reflecting on the memories that it has, it slowly builds up like a self-identity, which is something that I would like Muse to be able to do, which is basically what this little ego cloud is up here. That's all for today. I will see you soon.